How many people here, I know we still have 3 minutes, so I just thought I'll get to know you a little bit, and you'll get to know me. How many people here work as developers? Raise your hand. Okay, expected. How many people here work as security? Okay. Ops. Compliance. Marketing? What am I missing? What other interesting categories do we have? No, there is no DevOps, sorry. There's Ops. Is there any other category? Don't tell me DevSecOps. Don't tell me DevTestOps. Don't tell me GitOps. Seriously, this talk is about why all that stuff is just... I'm just going to do, for the next 40 minutes, I'm just going to do... That's how you get to know me. Okay, go on. A little bit about me, since we're just waiting anyway. So I've been working... I thought it fell. It fell in my previous talk, too. So it was a sign. Literally a sign. So I've been in the software industry for over 20 years. I started in Visual Basic. Visual Basic? A few old bastards here. So don't hold it against me. I still remember Visual Basic, and I liked it, okay? Screw you all. I liked it. And I even used SourceSafe. And it did not break for me. Sorry? I didn't go big enough. That's... I'm not going to answer that. So, I started in Visual Basic. I moved on to C#. I just jumped over VB.NET. It was like... and then we did a bit of Ruby and Python and Java and JavaScript, of course. These days, I'm actually rewriting my book on art of unit testing for JavaScript. And I'm working on a new book called Pipeline Driven, which is basically the essence of this talk. And this book is, to me, is about what does it take to enable true continuous delivery. And that's why I asked about the different categories of people. Because if we have different categories of people, they have to work in the organization, and we're trying to do continuous delivery, those people have to talk to each other. They have to work together. And I find that, like Jerry Weinberg said at one point, all software problems are people problems. So this talk is not going to be a technical talk. It's going to be a people talk. If you want to hear more about the subject, if you want to read more about it, I have a blog called at pipelinedriven.org. You can just tweet me at Roy Osherove. There are 3 key points we're going to cover in this talk. I'm going to talk about cooperative pipelines. What does that even mean for true continuous delivery? How is that different from pipelines that we have today in organizations? What are the different skills and cross-stack skills that we would need to work in cooperative pipelines? And why it's actually in our best interest to move to that type of pipeline. So first, this. You know the standard talk that talks about the Netflixes and the Googles and the Facebooks, how they deliver millions of times a second and all that good stuff. And then when I go to these organizations and I consult for, and I ask, do you do continuous delivery or continuous integration? They say, of course. And somehow it is a completely different experience than these organizations. And what I've been seeing as you consult for more and more companies, and you do training and you work with people, you realize that there are patterns that repeat or don't repeat when we're not talking about these companies. So what do we see in real-world organizations? Or let's call them traditional organizations. I wouldn't say waterfall organizations. Let's call them SDLC, Software Development Lifecycle 1.1, which are the organizations that are trying to move towards continuous delivery and are somehow failing at it and find it very, very difficult to move. So what usually happens? So in these organizations, we do have pipelines, right? How many people here have a bunch of Jenkins jobs or something like that running all over the organization? Okay. How many people are actually doing continuous delivery per commit? Exactly. Oh, one person, 1.5. Okay, so why is that? What does that mean? In organizations, a lot of times what people do is they take some of the technical ideas and they try to implement them on the current process. So you'll find that developers have pipelines that they run. They run the unit tests and they run maybe some integration tests. And then in many organizations, the bigger ones, developers will then hand off the code to the testers, which run their own pipelines. So testers, maybe they're not even doing manual testing anymore, maybe very little, maybe there's a bunch of automated tests, maybe there's an automation team, and they have their own pipeline. Does anyone here have that? Like a separate team that have their own set of tests, they run at night, and then to understand if the tests fail, because they're always red, we need a translator. We call them the build whisperers. And the build whisperers is the person you go to when you see that the build is red, but you don't know if it actually failed. So you go and you say, is it actually failing? And then the build whisperer will go, based on my huge intellect, I will describe this build as green, even though it's red and 3 tests are failing. Okay, it's green. Let's go to the ops people and try to actually deploy that thing into the next environment. Ops people have their own pipelines. It's all automated, folks. We have CI/CD. So they have their own Jenkins jobs and they run and they push that stuff. Of course, they are the only ones who have permission to do that stuff. So when they say it's okay, they go, okay, you may now use this new environment. You may now deploy this, but then the security folks come in. Right? Security folks, where are you? Just put a big target on your back, right? Security folks come in and said, hold on, all that nice stuff that went before, that was nice, but that was child's play. Now we're getting into the picture. And the answer is no. What is the question? We do not care. The answer is no. And we'll find out why the answer is no, because what you'll hear from most security people, they want to do the right thing. They want to help the organization, but the incentives are completely wrong. So, we have this huge convoluted waterfall pipeline. So we have a lot of automated jobs, but it still somehow magically takes us 5 months to push a change into production. Do you understand why? We don't really do continuous delivery. We just have waterfall pipelines. So the difference between this and this, right? If we think about this waterfall pipeline, we look at it and we say, okay, so technically our process is that the same piece of code goes from the left to the right, and there are people in the middle of all of these actions. There's a bunch of automated pipelines, and there's a bunch of judges in the middle. And those judges get to decide, get to veto what happens in the next stage. What if we got rid of them? Right? What if instead of making the tactical decision of whether we move forward to the next pipeline or not, we just move to the next pipeline? Now, how would we move? It's very easy. If the pipeline on the left was green, then we start the pipeline on the right. And if that's green, we start the pipeline next to it. If that's green, we start the pipeline next to it, and next to it, and next to it. No people in the middle. Now, some of you are looking at this and are listening to me say this and say, yeah, no way will this work in my company. Because in many companies, just the thought of removing humans from the process of that human judgment feels like it's going to be suicide. And the reason is we don't trust our pipelines. We don't create pipelines, automated pipelines, that we can trust enough so that if they're green, we actually move forward. And I would argue that this is the difference between a pipeline-driven organization and just a bunch of automated Jenkins jobs running around. Okay? Because if this is all automated, we can also parallelize it, right? We can run a bunch of different tests in parallel and only then move to security, which are automated, and compliance, or just do the deployment, but there are no people in the middle. So what are the benefits of that, right? What are the benefits if developers and testers and ops and security and compliance, instead of making the decisions themselves, those tactical day-to-day decisions, they teach the pipeline. Notice it's a single pipeline, okay? It's a single pipeline made up of decisions. And those decisions are coded as tests, because tests are either green or red. Now, if you have today builds that are not green or red, hear me out. If you have builds that are yellow or orange or anything that is not green or red, huge mistake. Because it means that you don't have a definitive answer. A build should either fail or pass. That's the way we use builds. If a build is orange, we need a build whisperer. Okay? So, if we teach a build to make good decisions, maybe we can get rid of some of the decisions we make as people. What's a tactical decision? A tactical decision is not the same as a strategic. Strategic decision is what do we build? A tactical decision is, do we move on to the next pipeline? Do we merge to this branch? Do we deploy to this environment? Do we change a version? These are the day-to-day tactical decisions that we always wait for people to make decisions for us. And those people are bottlenecks. So, approving a merge to master, approving a release. How many people here work in the testing capacity in some way? How many people have to work with people who are testers full-time? Okay. Have you ever been to this hugely amazing, beautiful, scary situation? The test lead comes in before the release, and then they have to sign with their blood that the release is going to be okay. Because the previous version failed, and they also signed with their blood. So this is the third version. So now they are faced with this huge, beautiful, amazing issue. Do I, Roy, as a test lead, allow my entire job to suffer based on something that I have no idea what is in there, because the amount of code that happens in there is too big for a person to actually know? Do I sign it off? How do I sign that off? And the answer is, with many parts of me shaking. That's how I sign that off. Or I don't even sign. I say, no, I'm not signing off on that. Let me just verify, because my future is on the line if that stuff is missing. I have no control over that stuff. And yet I'm somehow supposed to sign off on that. But what if, instead of me signing off or saying that it's not good, because if there's a scarier thing than saying that something is okay, it's saying that it's not okay, the test lead. Because then you have to delay the version. The test lead also, again, delayed our version because they say it's not okay. Now I'm like the asshole who's trying to say, no, the version is not good enough, and everyone is pressuring me to approve a version. But if the pipeline is just red, that stress is lifted. I just say, no, what do you want from me? The pipeline is red. Make it green, and it will be approved. You don't need me for that. Reduce the amount of stress. When we're putting people in the middle, we're asking people to do a job that is not made for humans, which is to verify and to check a lot of different things repetitively, and just to get the confidence we need. What about security? Security approving an application. We have a few security folks here. It takes a lot of guts to approve an application in terms of security, or not to allow, right? What if the pipeline was just red? What about ops? Deploying a new environment, rolling back, killing an environment. All of that stuff, today there are people in the middle, and we can just get rid of them. And one of the nicest things about this, we just remove stress from our lives. We remove stress because most of the work now happens on teaching the pipeline. So instead of me just sitting there and looking at the pipeline and then turning around and saying, I think that stuff is okay, I teach the pipeline to say that something is okay. And then job continues automatically. So most of my job becomes teaching pipelines. Most of my questions become, do I trust the pipeline? So how do we trust pipelines? This is what I call SDLC 2.0, right? Pipeline-driven organizations, organizations that remove people from the tactical day-to-day decisions. And the Netflixes and the Googles and all those people, the reason why I think they're successful is because they've done already this. If you look at the way, whenever you read a blog post or you read a book about how those organizations are delivering software, you will see that pipelines make almost all of the decisions. And if something goes in, it goes out automatically. There are no people in the middle. That is the core difference. So how do we participate in a pipeline? If I'm jumping into this brave new world, how do I, as a security person, as a tester, as a developer, as compliance, as ops, how do I participate in that single pipeline? Well, I think of it like the UN. In the UN, we have delegates, right? The delegates represent different countries and different interests. Delegates get to vote, but in a cooperative pipeline like we're talking about, each delegate can veto. So it only takes one delegate to veto the entire pipeline. Okay, one red equals a failed pipeline. And our job is to create the best delegates in the pipeline. So each of the categories of people that have specific expertise in the organization then work on adding those delegates into the different decision points in the pipeline. So if I'm specifically an expert in security, I will make sure that the security tests represent my interests. So they are either green or red. The same for infrastructure, the same for testers that think at a higher level, same for developers that think usually at the lower level. Compliance, I don't know if I asked compliance before, but compliance should totally be part of that pipeline. Compliance is much easier to check than most people realize. When you ask compliance folks, what are you actually checking when you're doing compliance? They'll tell you, well, I'm making sure that the tests for something have passed, that the reports are there, that something has been signed off, that specific documents exist. A lot of very menial, very easy to automate tasks. We could automate that. We could teach people to create delegates in the pipeline that pass our compliance pipeline as well. Does anyone know how do you veto a pipeline? How do you make a pipeline fail? Can anyone tell me? There's a bunch of developers here. How do you make a pipeline fail? Tell me. Sorry? Bad test, bad code. But technically, what causes pipelines to fail? What causes a pipeline to tell you that it failed versus succeeded? Can anyone tell me? Exit codes. Exactly. If you want to make a pipeline fail, all you have to do is return with an exit code of non-zero. Here's how you do it. If you want to participate, all you have to learn is how to make a process return non-zero. In fact, if there's one thing that scripts and CI servers agree on, is that non-zero equals failure. Doesn't matter where. All CI servers everywhere already agree on this. All you have to do is in your process exit with a non-zero value and your pipelines will fail. So that's how we veto. Now what's left is to actually put those delegates in the pipeline, which means it requires us to learn different skills, like how do we edit the Jenkins file or the Circle CI or whatever it is that we're using. How do we actually manage that file? And those skills are learnable. So when I do this talk, I usually do this talk for multiple different categories of people. And each one of them in a pipeline is required to learn a different set of skills or a common set of skills. Because developers, most of you today, are already going through this transformation. Whether you like it or not, your organization is trying to get to that continuous delivery holy grail, or at least trying to say to everyone that they're doing it. And in the process, there are things being pushed to developers, and they're required to do things they've never done before. For example, learning about full stack development so we can create feature teams, and learning about security. How many developers here have been asked to start learning about security? Anyone? It will happen more and more. Infrastructure automation, learning about stuff like Terraform or understanding Kubernetes, things that we've never had to learn before and we now have to learn. Learn automated testing, not just at the unit level, but end-to-end testing and a bunch of that stuff. You'll hear developers complain, that's not my job, dude. Why are you forcing me to do that stuff? And coaching for other categories of people. For example, ops. So there are no DevOps people, right? We know this, correct? There are no DevOps people. It's just a new name for ops people, which is a new name for IT folks, systems folks. But here's the thing. In this kind of a pipeline-driven organization, the role of those people is changing. And that's why, because we don't have a better name, we use the term DevOps. But really, these are people that have expertise in arranging and creating and configuring systems, but they have to learn new skills as well. Infrastructure is code. They actually have to learn how to code. A lot of them don't know how to code. They might know how to write a few scripts, but do they know how to code? because, for example, Groovy is the simplest language you're going to have to learn how to code. But automated testing, because ops folks have to learn how to test the infrastructure as well. Otherwise, they're going to have to build it and verify it manually, which is the opposite of what we're trying to achieve. Also, if we're coding, everything goes into source control, right? So we have to learn how to connect all that stuff into pipelines. So a lot of ops folks are not just learning about Kubernetes and all that. They're learning about configuring pipelines. And in fact, they're already going too much to a specific way, and they're taking over pipelines. So in many organizations, what happens is that this whole thing with pipelines already begins to be someone else's problem, which is those folks over there behind the door, because that's not my problem as a developer. And I would argue it's not true. We should be coaching each other about working with pipelines. The teams should own the Jenkins files, etc. Security folks. So if developers are already on their way, security and ops are definitely on their way as well. They're feeling the pain. Security folks are still far from it. They're still kind of sitting in that corner room, maybe sometimes in a different continent, living in their own little bubble, whether they like it or not. Some of them want to contribute, but they're not being pulled along into this continuous delivery story. Which means that when we start incorporating security into pipelines, because we want to do continuous delivery, then security folks will have to learn about automated testing. The nice thing is that most security folks already know about automated testing. Most security folks already have automated tools and scripts to test a bunch of stuff from here until next week. They just have their own little pipeline to do that stuff. What we want is for them to integrate into our own common cooperative pipeline. So coding new types of tests, not just scripts, coding decisions into the pipelines, and coaching developers and testers and everyone else about security, because security has to become everyone's problem. So when I write code, and my definition of done for that code could be that it passes this set of tests. Those set of tests could also be security tests as well. So when I start coding it, I will already need some security coaching on what types of tests could be written, maybe at a unit test level, etc., to make sure that my code is secure. So security will feel the pain. I don't think that they're feeling a lot of the pain today. And then testers. Testers definitely feel a lot of pain today. Many organizations, I came from another conference, from Øredev, where it's all about testing, Hungarian software testing. And half of the talks were about, is your job safe? Will AI take over? Are robots taking over your future? Are you going to get fired tomorrow? What do you have to do to survive in this new world? Jesus Christ, how scared is everyone, right? And I fully understand them, because in all these organizations that are trying to move towards continuous delivery, this kind of notion that, we're moving testing into the development, so there are no testers are not needed, or everyone should be coding, and testers that don't know how to code have to live in this future somehow, they cannot survive, etc. There's a lot of fear, right? So I think testers still bring a lot of important stuff to the table. They think about things at a higher level that developers don't usually do. They look at the system and they look at the scenarios for testing a system in a way that developers don't usually think about. Just like developers have read books from design patterns to, a domain-driven design to a bunch of different skills in development, testers have read parallel books about architecting software tests and understanding software different scenarios and generating different ideas and how to approach different problems. There is a whole set of skills there that's running in parallel that they have to learn from each other. So in that new world, testers not only have to learn about automated testing, that's kind of a given, because they have to put the delegates in the pipeline, right? And those take the form of tests. They also have to learn about coding and best practices in coding, and then they will have to take that from developers. They will have to learn about test infrastructures, and coding those test infrastructures may be running on specific environments and understanding how that connects to pipelines. And they will have to coach other people, because the good news is that in a pipeline-driven organization, everything is a test. And if I'm a tester, suddenly my skill actually means more. Because everything is a test, everyone needs to learn how to test stuff. So I get to, if I want to, start coaching people on how to write good tests, because they don't have those skills yet. So I put in different colors the different skills that people from different categories will have to learn. As you can see, like the red stuff is security, the blue stuff is testing, the green yellowish stuff is coding. There's a lot of, this is what I call cross-stack skills. Not only you, now developers are like, well, you push me to full stack, now you're like going cross-stack. What else do you want from me? How much, what I've already given everything to this organization, now you want me to also do that stuff and that stuff? And the answer is yes. Yes, exactly. This is our new world. You're going to have to learn to live with everyone. Every one of those people is going to have the exact same pains as you. They're all going to have to learn. Ops are going to be like, oh, come on, I already know how to do this. Now you're asking me this. I gave my everything to this organization. 20 years, now you're asking me to do test infrastructure and write automate that. Screw you. No, we're all going to have to go through this together. If we don't go through this together, then we're going to create those silos. We're going to jump into waterfall pipelines again. And we already know how that ends, right? Just exactly where we started, only with automated jobs in the middle. So, for developers, what's in it for you? Stress. Developers are already kind of there. A lot of developers are writing unit tests and automation. But there's job security because cross-stack means that you are more hireable if you're able to work on pipelines and you understand security and you understand infrastructure and you understand how to test. If you have those skills, then today you are much more hireable than a developer that comes in with only development knowledge. And I think you're already starting to see that stuff. There's professionalism coming in. If you want to get better, I think this is the next brave new frontier. I don't think AI is going to be the thing that is going to save all of us from all of that stuff. When AI comes, all it's going to be is just going to be another dot in that waterfall pipeline, and someone is going to look at the AI pipeline and make decisions, and we're going to be in the exact same spot. The difference is removing people, and that is an organizational process. And we won't have to wait for other people. You want to make a fix to something, you put it in the pipeline, and if everything goes through, you should have a fix in production, minutes, 30 minutes, definitely today. For testers, less stress. Testers are one of the most stressed individuals I've seen in the IT industry, for good reason. Everyone is going, looks like everyone's going after their job. But the truth is, the testers possess a bunch of skills and the marketing for that knowledge doesn't exist yet. People don't realize just how much testers know about the application. And I'm not talking about the tester who doesn't really know anything that you have there. Because in every company there's a bunch of people. Sometimes it's testers, sometimes it's developers, sometimes it's ops people, and they don't have the experience. I'm talking about the experienced ones, the ones who know what they're doing, who came and have failed their share of failures, and they can guide you towards a better testing strategy for a specific feature. So for them, there is job security in this world because I don't think they stay testers. I think they become test architects. And test architects are basically like architects. They move around between teams and they coach teams and they help to generate knowledge. And they do take part in the development of writing the automated tests at specific levels. And if you want, at my blog, there is a whole post about test recipes and how that practice could be something that we can use in the future to combine dev and test workflows. DevOps folks, less stress. If you are going through and trying to manually create and configure an environment, how much stress is it in there when the environment fails, when we're trying to push something in and we're not able to because the environment is dirty, raising up a new environment? In fact, what I've seen in many organizations with the advance of Docker and Kubernetes and all that nice stuff is that even though we have now this containerization revolution and the ability to create something dynamically, organizations still have static environments. So if I ask development teams, they'll say, well, we deploy to the dev environment, and then after ops approves, we push it into the staging environment. And I ask, aren't you using Docker and Kubernetes? And they say, yes. So why do you have static environments? Why do you have an environment that runs 24/7? You could technically create such an environment for every commit. A new environment per commit that runs those tests. You don't have to wait for anyone else. No one else has to wait for us. We immediately get that feedback. And when I ask why, the answer is because we've always done it that way. So we've moved from static environments on virtual machines into static environments on Docker. That's the only difference. Even though Docker supports a lot more interesting scenarios, the knowledge of having dynamic temporary environments doesn't exist yet. That is the stuff where people have to learn and slowly learn the skill that not only do we use tools, we use them to remove bottlenecks. So the next skill in this organization, and a lot of times the ops folks are the ones who can see it the most, is removing bottlenecks from the process. And environments are one of the biggest bottlenecks in teams. Oh no, we're going to have to wait for that environment, and people are using this from 9 to 5, and it takes a long time to load this one, and until someone gets deployment because we don't have permission. Screw that. Give me a bunch of Docker images, configure that stuff, load it up, run tests on it, kill it. That's where we should be going. And this is where, in terms of ops culture, this is where ops should be pushing for, but they shouldn't be the ones creating it. They should be coaching developers. They should be coaching testers on these environments and how to create those steps in the Jenkins files, etc. Because the teams, the development and testing and the ops and security, they should be working as teams, and they should be changing those steps in the Jenkins file. Security. If you're working in a pipeline-driven organization, you're going to have much less stress. The biggest stress is that you're going to have, instead of you having to say no to everybody, the pipeline will say no. Isn't that nice? So you're going to have an automated no. But sometimes it will actually say yes. So everyone's going to be happy. Okay? So instead of us being stressed that we're actually going to do something wrong, we teach the pipeline to the point where we trust it to make good security decisions. We have a bunch of security experts here, especially Niall here. And when I showed this to Niall, he completely told me, you connected to this, it makes sense to you, right? As a security person, security-focused person. So these things, we don't even sometimes speak the same language as security folks. We don't even know that we don't know about something. So in terms of job security, right? Security, job security. In a pipeline-driven organization, security happens during development. So how does that happen? Before I start working on a new feature, I create a set of scenarios for making sure that it actually passes. And I brainstorm with the test architect and maybe with the security architect. We sit together for 5 minutes. We write a set of scenarios. I'll show you what it looks like in a couple of minutes. And then that test recipe becomes kind of our definition of done. And during that conversation, that's where we learn from each other. Instead of one person coming up, these are my tests and these are my tests, and deal with it, we write those test recipes together as 1, 2, or 3 people, and we create kind of this huge knowledge base that incorporates the knowledge from testers, the knowledge from developers, knowledge from security, and hopefully the knowledge from infrastructure as well in terms of features. So I'll give you one simple example of where test architects fit into that vision. So test architects, to me, is the next evolution of where testers can come in. They're part of the planning process and the discovery process, and they coach developers, but they're also coding tests. How do they code tests? Well, the test recipe is one such practice. A test recipe is basically a set of, it's a practice that's made for knowledge sharing, right? So imagine the iteration is started and you're working on this Jira item or whatever item you're working on. Before you actually start coding it, you get together with the test architect and you brainstorm and you write a bunch of lines in the Jira item or on paper. I would recommend right under the definition of the item you're working on. And then you decide for each line at which level that test is supposed to happen. For example, If I'm sitting with a test architect, I might say, well, I'm going to write, these scenarios might pass, I think I would test these. Test architect might come in and say, have you even considered these types of scenarios? And then I would say, oh, I didn't think about that because I'm a developer. I usually don't think at that level. That's interesting, and we would start learning from each other. And I would explain in terms of development that some things are better tested at a lower level. Oh, I can just unit test that stuff. We don't need to go through the entire page to test the entire thing. Maybe if we decided something is end-to-end, we could define that for the top scenario, as a developer, I would need to create some special hook or a special query parameter, or a special secret page, or a token, or something to enable that special end-to-end scenario. So now we have a few benefits. First of all, we don't duplicate tests between different teams. Second, we learn from each other. We also make sure that for a specific feature, we have different types of tests at different levels, and we don't only focus at the highest level end-to-end, or only at the lowest level, because that's a very common thing that happens in organizations where dev and test don't speak to each other, is that you end up with a bunch of end-to-end tests and a bunch of unit tests, and nobody cares about the other. If the end-to-end tests fail, I have no idea about it. If the unit tests fail, they have no idea about it. And this is a very common thing. But here we're creating a single test recipe for a specific feature, and when all of these are passing, we ask ourselves, if all these are passing, are we okay? Are we confident this feature is working? If the answer is yes, I think so, then we go ahead and we actually split and we start working on whatever we decided each one works on. Right? If the iteration is started, then there is a meeting that happens 5 or 10 minutes at the beginning of the iteration per feature, where 2 people are working on it, 2 people are responsible for finishing the feature. And if security is there, we can also include security as part of the test recipe. This is just specifically for test architects, just so you can see how that thing happens. So why is this important? We have miscommunication, we want to prevent. We have duplication that we want to prevent. Right? If you're looking at this and you're saying, well, that's a test plan, and the answer is that's not a test plan. That's a comment in the code. Okay? That test recipe is just a development ad hoc design, a bunch of scenarios. You're not committed to it. You can change it. You can add more stuff to it. It's a very fast moving thing. You don't have to document all the steps like a regular test plan. Instead, in that world, there are no test plans other than the test recipes and the automated tests and the reports that they generate. So in that regard, we have like 6 minutes left, correct? Right? Okay. So in that regard, the test recipe removes duplication, allows coaching from both sides, because as a tester, I want to understand what can be enabled and what can be automated and what can be removed. I can avoid unnecessary documentation. I can do a lot of amazing things just because I talked to someone. And I think all of you, if not most of you, have been in the situation where there was a huge miscommunication that has happened for weeks or sometimes months, where huge things were created unneedlessly that were solved by a conversation of 5 minutes with a person. Oh, we didn't even need that, or those tests don't even make any sense, or we already have written all of that stuff, etc. Or why didn't you just tell me that instead of XPath you want an ID for testing? Simple stuff like that can solve hours and hours of work. And remember that the point is that the test recipe goes into the automated pipeline. So that's part of our decision-making process. So in that pipeline, when we are working on these scenarios, we have to decide at which level those are happening. And pipelines, usually, and this is true for all of the categories of work, we can write things at a very low level, and we get very, very fast feedback. And we can write tests at a very high level. We can get great confidence, but the maintainability and the runtime are very, very slow. So in organizations where we started, a lot of times what I see is that organizations just have a bunch of end-to-end tests. They just have that, and at that point, it takes hours and hours to run those. And when it takes hours and hours to run those are also very flaky tests. And then we get back into the situation of the build whisperer, okay? And then we have organizations that are completely, no, we're developers, we're writing very, very low-level code, we're moving very, very fast, we're getting feedback, but the confidence is not specifically high. And then we have this situation where we have these two different categories working separately. And so now we have both of the maintainability issues, code that no one wants to maintain, and then we have low-level code that the developers trust more because they didn't write that code. They have no idea how it works. It might even live in two separate repositories. So I would recommend as a testing strategy that is more pipeline-friendly is to think about the tests in terms of coverage for a scenario, is to always prefer the lower level until it doesn't make sense. So if I have happy path, let's see if I can highlight this here. So if I have a happy path here, this is a scenario. Imagine a login, okay? So the top level of a test is kind of like these kind of huge things on top of me here. There's these huge pipelines, right? These huge things that are holding together a bunch of smaller things. So the top test is our clothesline. It helps us to see that there is a connection point from all the layers of the application. But if I wanted to test a variation of that scenario, I don't need to create another test at that level. I will test that variation at a lower level, maybe at the API level, integration level. And for those variations of this scenario, I would test as unit tests. So if I've already tested that login succeeds at the end-to-end level, what if I wanted to simulate a login that doesn't succeed? I would test it at lower levels. What if it doesn't succeed has like 15 different variations? I would test it at a lower level. So this type of layering strategy gets us two things. It gets us faster feedback, but it also gives us confidence. And confidence is the missing metric in a pipeline-driven organization. So when I work in a pipeline-driven team, I ask, not only I measure coverage, I always say that coverage is meaningless, right? 100% code coverage doesn't mean anything. Because I can get you 100% code coverage and the test would suck. Right? 10% code coverage definitely means something. It means we're missing tests. So how do I measure? What's the point of this? The point of these tests, it's to get confidence. So I would periodically, at the end of every iteration, I would ask the team two questions. What is your confidence level in the code today that it does what it should do? Right? From 1 to 5. Maybe they'll say 3, 3.5, whatever. And then the next question is, what is your confidence level that the tests will find a problem in the code if there is a problem, from 1 to 5. And I just take these two metrics and I trend them over time. Because it doesn't matter if it's a 3 or a 4 or a 2. What matters is it goes up over time. It doesn't matter how accurate it is. What matters is that the people get more and more confident, and that is something that we cannot fake. We cannot lie our way through this. So just to finish off, we have these cooperative pipelines. What makes true continuous delivery is that people are not making the day-to-day tactical decisions. But to make that happen, we have to create pipelines that we can trust, which requires us to learn new skills, which all of us are already learning. We just don't have a good name for it. But we're going through this whole transformation, and I think this is where we're going to end up. And a lot of companies, like the Netflixes of the world, are already doing it. They just don't have a name for it. For lack of a better name, everyone calls it DevOps, and then there's DevTestOps and SecOps. Forget that stuff. We are working in a pipeline-driven organization. To me, that is the true meaning of the thing, because tomorrow there's going to be an AI ops, right? And there's going to be, I don't know, floor ops and whatever ops. What are you trying to say here? Is that we're all working in a cooperative pipeline. We can all veto, we can all enable true continuous delivery in our organization. And it's in our best interest to learn these skills today, because they're going to be needed no matter what, whether we like it or not. This is where the industry is going. If you want to learn more things, you can go to pipelinedriven.org. I have a whole blog about it. You can tweet me at Osherove. Thank you very much. May the force be with you.